Hello, good morning, all. Good morning, welcome again. Yes, today we'll be showing you guys how to go along with dimension of physical quantities. Okay, we have this problem before us to explain. Question says a physical quantity is given by the equation Q. A physical quantity Q is given by the expression Q is equal to half rho v squared. So where P is rho is density and v is velocity. We are told to determine in question A, determine the dimensions of Q, and then in question B, we are told to find out the physical quantity that Q represents. Okay, so we go like this. So we start with A to find the dimension of Q. Okay, so this is question A. Question A. Okay, what you need to do here is to bring down the formula Q according to this question. Let's look at it. It says Q is given by this. Q is equal to half rho v squared. Okay, we are told that rho is density and v is velocity. So the next thing to do is let's find the dimension of density. Density rho is actually density is mass over volume, but like we know density is mass over volume. So what we do here is to find the dimension. Mass, the dimension of mass is capital letter M. The dimension of volume is L raised to power 3, L cubed. So this means that the dimension of density is actually mass M, L raised to power minus 3. Okay, so the next we do is to find the dimension of velocity and then multiply them. Then velocity is distance over time. Okay, velocity is distance over time. We know this formula. And the dimension of distance is the same thing as length. So dimension is L. Then dimension of time is T. That means velocity is actually LT raised to power minus 1. That's the dimension of velocity. So what we'll now do is we're going to put that into this. We're going to substitute that here. But remember, when you do dimensional analysis, we don't work with a constant. We don't work with a constant. 1 over 2 is a constant, so we're going to assume that it does not exist, so we ignore it. And when we do that, so what I'm going to do is to substitute the dimension of density and dimension of what? Speed. But this speed is squared here. This speed is squared. So if I square this, here, if I square this, that means I'm going to have this L is going to be squared and this T is going to be raised to power minus 2. Raised to power minus 2. Let me rewrite it so that you understand. The speed we are talking about is squared. So this is formula, this is dimension for speed, which is L T raised to power minus 1. But if speed is squared, so what I'll do is square here, square this, square the whole of this. Okay, square the whole of this. And then so we come back here and put the dimension for the density, which is M L raised to power minus 3. Then we multiply it. We multiply it by L squared. If I open this square, this is going to be L squared T raised to power minus 2. Okay, so that's what we're going to have. And then when we have that, the next thing we're going to do is just to solve this. And then if we solve this M here, we're going to have this M L raised to power minus 3. Here I have L raised to power minus 3. Then this L times L raised to power 2. So if I multiply L raised to power minus 3 by L raised to power 2, I'm going to have L raised to power minus 1. And then this will also be times T raised to power minus 2. Okay, so the dimension for Q is actually given by M L raised to power minus 1 T raised to power minus 2. That's the dimension of Q. Okay, so the next we're going to do is how do we find what quantity is Q? What quantity is Q? That is B. Now, since we got the dimension as this is the dimension here. This is actually the dimension for pressure. So we said our Q actually represents pressure. Our Q represents pressure. So we have answered this question. We have answered this question here. And that is how to go about this question. That's how to go about this question. You can see the dimension here is ml raised to power minus 1, t raised to power minus 2, and then the quantity is pressure. Thank you.